Hey everyone, the given question is from the topic of current electricity. Okay, it is from JEE Advance 2014 paper 1. So the question was like this: the time t equals to 0, terminal A in the circuit shown in the figure is connected to B by a key. And alternating current IT is equal to this, and I naught is equal to 1 ampere, omega is equal to 5 rads per second starts flowing in it with the initial direction shown in the figure. At t equals to 7 pi by 6 omega, the key is switched from B to D. Now onwards, only A and D are connected. Okay, a total charge Q flows from the battery to charge the capacitor fully. So if C is equals to 20 microfarads, I think there is a printing mistake, and R is equals to 10 ohms, and the battery is ideal with EMF 50 volts. You need to identify the correct statements. Okay. Now, we have been provided with I of t, which is equals to I naught into cos omega t, which is equal to dq by t, and this will be 0 when the charge is maximum, right? So we can say that when this guy is equals to 0, the charge will be maximum, and that happens when omega t is equals to pi by 2, 2n plus 1 pi by 2. Okay, so which is 2n plus 1 pi upon omega, which is not 7 pi by 6 omega. So option A is wrong. Okay, now the current in the left part of the circuit just before t is equals to 7 pi by 6 omega is clockwise. When t is equals to 7 pi by 6 omega, this value is negative, so it is not clockwise, in fact it's anti-clockwise. So this is also wrong. Okay, option B is wrong. Immediately after A is connected to D, the current in R is what? Okay, see, what is the charge when t is 7 pi by 6 omega, right? So for that, we know dq by dt is equals to I naught cos omega t. Now that implies that dq is equals to I naught cos omega t into dt. Now we integrated it from 0. Initially it was 0, right? It was 0 to some q. Let's not write it q, let's write it q. Okay, and this went from t is equals to 0 to 7 pi by 6 omega. So basically I naught sine omega t upon omega from 0 to 7 pi by 6 omega. All right, so this is I naught. It is basically sine pi by 6, that's sine 30, so that is 1 by 2. Okay, minus and omega, right? So I naught is 1 ampere, so we'll write 1 over here upon 2 and into 500, right? So it's basically 1 microcoulomb, that negative 1 microcoulomb, that is the charge present. Okay, now negative implies that here we have minus and here we have plus. Now we'll apply Kirchhoff's law over here. Okay, so from KC, Kirchhoff's voltage law, KVL, we can say that 50 plus 1 microcoulomb upon 20 into 10 to the power minus 6 farads. Okay, that is equals to I into R. All right, from here we can get the value of the current, which will say if the option C is correct or not. So 50 plus 1 into 10 to the power 3 upon 2 into 10, so this is 100, 50. So and R is basically 10, right? So 10I is equals to 100, I is equals to 10 ampere. So option C is correct. This is immediately after, right? Option C is correct. Now the charge passed through the battery, that's what capital Q is. So that implies initially whatever the charge that is present at the capacitor and minus the charge that is present after a long time will give you the answer. After a long time, the capacitor behaves like it's an open switch, but it has a potential difference in that, a bit among, like in between, okay, on the both side it has a potential difference which will be 50 volts, okay, right. So that implies that Q final upon C is 20 into 10 to the power 6 is equals to 50. Okay, so Q final is basically 100 into 10 to the power 6, which is 1 microamp, 1 microcoulomb. Okay, so basically Q final minus Q initial, which is minus 1 microcoulomb, will be 1 minus of minus 1, okay, which will be equal to 2 millicoulomb. Okay, 2 millicoulomb. I think I said micro, I meant milli, it's millicoulomb. Okay, this is 10 to the power minus 3 coulomb. So option D is correct. So the correct answer to this question is option C and D. Thank you.